Distinguished guests, ladies and gentlemen, I welcome each and every one of you here to this, the UNSW Medicine Dean's Lecture Series. In welcoming you, I acknowledge the traditional owners of the land on which this university stands. If you look at history, ladies and gentlemen, when this building was built some 40 years ago, there was a lot of discussion at council about whether we could ever fill it. And I have to tell you, it's a pity that most of them aren't here today because we've taken every seat in the auditorium. I welcome each of you because each of you have some involvement here with the university or with the subject matter or with medicine in general. There are members of our alumni here, we have some of our donors here, we have medical practitioners here, friends of the medical school, friends of the university generally, and each and every one of you are very welcome here tonight. I'd like to particularly welcome the Director General of New South Wales Health, Dr. Mary Foley, who's here, and I'd also like to welcome Dr. David Kennedy from Atlantic Philanthropies, one of this university's most important donors. I welcome also Daniel Gaucher, who's Chair of the Medical School Advisory Committee, and members of his committee as well. I would like to warmly welcome our three speakers, Baroness Professor Susan Greenfield CBE, who flew in last night and tells me she's still got jet lag, which is amazing because it's been a whole 16 hours. Professor David Sinclair, he's the only professor of Harvard who wears religiously a University of New South Wales alumni tie, and we're very, very proud of him, David. And finally, Scientia Professor Henry Brodaty AO, and if you don't know Henry, you don't know anybody. I'd also like to welcome Ita Buttrose, and it occurs to me, Ita, who's an AO OBE, if you don't know Henry Brodaty, you probably do know Ita Buttrose. It's incredibly exciting for all of us here at this university to have the turnout, and I'm not surprised because of the quality of our speakers and indeed our facilitator. So what does a mere chancellor do surrounded with this intelligence to make his presence here worthwhile? Well, what the casebook says for chancellors is you announce something, and that's what I'm going to do. Indeed, I'm going to make two announcements tonight. First, I'm delighted to announce that the University of New South Wales Medical School has been successful in matching dollar for dollar the $1 million challenge grant from the Thomas Foundation, which will be directed towards further ageing research, a subject of which we're all going to be listening to and talking about tonight. This means effectively that we've unlocked $2 million of philanthropic ageing research funding for this university. Our research will be led by Henry Brodaty, one of our speakers tonight. And the founder of the Thomas Foundation, Mr. David Thomas, who may be known to you, could not be here tonight, but he asked me particularly to note that he sends each of us his best wishes, but more particularly a message that funding is needed to combat the effects of global ageing, as he calls it. He's done his bit, and he'd really like others to follow. The second announcement is that we can now confirm that Professor Brodaty's chair position will henceforth be named the Montefiore Chair of Healthy Brain Aging. And I'd like to acknowledge the support of the Montefiore, who've provided $665,000 to support the work of Professor Brodaty and his team at the centre. This support is greatly appreciated, but like most support, it involves a lot of people. And I'd particularly like to thank and welcome their chair of Montefiore, David Freeman AM, who's here, their treasurer, Gary Imberg, who's also here, board members Tom Montner, Renee Simons, and Associate Professor Peter Gonski, all of whom are here tonight. The link with the Monty means a lot to us. We thank you very much for joining in this important issue and very much look forward to hearing the name being used, we're sure, in all the right academic and professional circles. I look forward to hearing what all of our people have to say tonight. I welcome you, and I now allow the man who actually, this is his lecture, I suppose, he's the dean, to have a talk to you. I introduce Dr. and Professor Peter Smith.
So thank you, David, and they were exciting announcements you made, I'm sure we all would agree. I also would just like to briefly welcome our three speakers, Baroness Professor Susan Greenfield, Professor David Sinclair, Professor Henry Brodaty, and also welcome our facilitator, Ms Ita Buttrose. I'd like to welcome and thank our Chancellor, David Gonski, our major donors, the VIPs, alumni, UNS staff and members of the public and university friends who are all here tonight. I just want to muse for a moment about the purpose of this evening. It reflects actually onto the role of a university and a medical school such as the medical school at UNSW. Our role is simply not to train medical students, and we do that, and I think we do it well. It's not simply to do research, and we do that in world class. But I think it is to host events such as this. It's to draw the strands out of research, to draw the strands out of the new knowledge that is generated by our faculty, and to develop a theme such as we've done this evening to engage with the community in an ongoing discussion. I think there are a number of measures of success of something like this, and while the lecture hasn't taken place yet, I think I can make a few comments. Firstly, the media interest in this event today was phenomenal. My phone started ringing at 6 a.m. this morning for interviews, and I've spent most of today talking to TV stations, talkback radio, various media outlets, and I know that our speakers have been heavily engaged with the media today. So this isn't so much just a lecture, it's now become an event. It was actually quite interesting, the engagement of community and of media right through to talkback radio in the topic that we're discussing tonight. Another measure of success, of course, is the fact that we've had over 1,100 people register with us tonight, and 100 of those are from our donor community, and there are about 300 people from our alumni community here tonight. In terms of media engagement, we have the ABC's Big Ideas program filming again with us tonight. And again, I'm proud to announce that this Dean's Lecture is the largest faculty-based event held on the UNSW campus. And since we started these community-based events in this format, attendance and interest has increased exponentially over 3 years. In terms of the university and the medical school, as you came in, some of you might have noticed the construction site on the corner. That is a $127 million project to redevelop the old medical school building, the Wallace Worth. We'll be building another building between the old building and the boundary, and then moving back and renovating the old Wallace Worth building. It was with a bit of nostalgia that I noted the first thing they did there was to knock over the old Dean's office right on the corner. Faculty had great delight in actually sending me pictures of the Dean's office being demolished. You will also have noticed the very bright green building, which is the $120 million Lowy Cancer Research Centre, which was completed in 2010 and is now undertaking cancer research into a number of areas. We're also a leading institution in neuroscience research and research into the ageing brain, led one of the leaders of that being Henry Brodaty, who's speaking to us tonight, is one of the cutting edges of what we're doing here. I also want to announce that Professor David Sinclair, who is a professor at Harvard University, will be joining UNSW Medicine as a conjoint professor in the School of Medical Sciences and will establish a laboratory to research ageing at UNSW and will be situated in our new Lowy Cancer Research Centre. So, with that, I would now like to introduce Miss Ita Buttrose, our facilitator for this evening. As the Chancellor said, there would be few in this room who don't know Ita, but she is a President of Alzheimer's Australia, Vice President Emeritus of Arthritis Australia, and the patron of the Macular Degeneration Foundation of Australia. She was made an Officer of the Order of Australia in 1988 for services to community and in particular in the field of medical education and healthcare, and for a work as Chairperson of the National Advisory Committee on AIDS. She also received an OBE for services to journalism in 1979 and the Centenary Medal in 2003 for business leadership in Australian society. I can't think of anybody who would be more appropriate to facilitate this lecture this evening. So with that, I hand over to Ita Buttrose.
Thank you very much, Peter. And good evening, everyone. I'm delighted to be among such distinguished company this evening, and I'm sure our brains will benefit by the challenges our three speakers will present to us. Now, I'm passionate about healthy ageing. After all, here we are, living in the world's longest period of longevity. Never before in the world's history have people lived as long as they live today. Even in the third world, people are living longer. And as we've heard, some of our speakers this morning were quoted in the Sydney Morning Herald and on the topic of that one day people will live to 150. And on the Today Show this morning, it was a hot topic of conversation, and I was one of the people who was asked to comment about it. So I've been talking about this topic on and off all day, really. And the baby boomers, of course, have leapt, they're so excited at the prospect of living to 150 because, after all, they are the ultimate Peter Pans of our society, aren't they? I mean, they're the people who are turning 65 and still insist that 60 is the new 40. But what is the point of having our longevity if we are not fit and well enough to enjoy it? A couple of years ago, I came across some books, Strong Women Stay Fit and Strong Women Stay Young. And the secret to achieving both of these goals was by using weights. So it made sense to me. So I found a trainer and I learned how to use weights properly. And it's one of the smartest things I've ever done because my upper body strength, which so often lets women down as they grow older, is in good shape. Jane Fonda, who is 73, wrote a book recently about ageing, and she was somewhat concerned about her libido, which was not up to scratch. And so she thought, to improve things, she would take testosterone. And it worked. Sex was great, but she started getting acne again. What a decision, good sex or acne? Who would like to make a choice? But if we're serious about healthy ageing, all Australians should be encouraged to do some kind of physical exercise. I've been brand ambassador to a company that builds retirement villages and aged care facilities in Western Australia for 10 years. And residents at the elder care facility are all in their 80s and 90s, and every one of them does some kind of exercise on a regular basis. And that includes light weights, which they use under the supervision of a physiotherapist. And if they can't get to the physiotherapist, she comes to them. And the results speak for themselves. The residents have fewer falls, better balance, they have a zest for living that has to be seen to be believed. Every aged care facility in Australia, unless there is some good reason for a person not to participate, should follow their example. Now, many of my voluntary health activities are or have been health-related. I don't know why I'm so interested in health, probably because I realise that it is the number one priority. You can have wealth, but without health, your money isn't much use to you. So yes, it was HIV/AIDS. I've worked with the Prostate Cancer Foundation. I've worked with Breast Cancer Centre. I'm a strong believer in preventative strategies, and I believe that Australia needs to be more vigorous in this area. As you heard, I'm patron of the Macular Degeneration Foundation. My father suffered from MD and lost his central vision. In recent years, the development of new drugs has meant that wet MD, there are two forms, wet and dry, but the new development in drugs has meant that with wet MD, the disease can be halted. You don't get any vision back that you've lost, but it can be halted. And we also know that changes in lifestyle and diet can slow down the progression of the disease, and it is thought also prevent people from developing MD. I've served as President of Arthritis Australia, and I'm now Vice President Emeritus, as you heard. My daughter was diagnosed with a rare form of juvenile arthritis when she was a teenager, and the arthritis community embraced me and never let me go. But we know that lifestyle changes can make a big difference with some forms of arthritis too. Every 1 kilo a person loses means 3 kilos is removed from their joints, and in many cases this delays the necessity for joint replacement. As National President of Alzheimer's Australia, a role I took on in February this year, my aim is to raise awareness about the high incidence of dementia and the impact it will have on all aspects of aged care. My father had dementia too. People with dementia often suffer from another chronic disease, and I have to tell you, with great respect to my dad, I sincerely hope I have my mother's genes, as far as my eyes and my brain is concerned. New figures released last week by Access Economics show that in 10 years, the number of Australians with dementia is expected to increase by almost 50% to 385,000. By 2020, just 8 short years away, some 75,000 baby boomers will be diagnosed with dementia. Yet for some reason, the federal government has terminated the Dementia Initiative, and Alzheimer's Australia's guaranteed funding stops in 2013. How can we plan without guaranteed funding? Dementia must be classified as a national health priority. We are campaigning not only to have our funds restored, but are demanding positive action through a $500 million dementia action plan over 5 years. And this will provide funding to promote dementia awareness, achieve timely diagnosis, provide quality dementia care, invest in dementia research, and make Australians aware that they may be able to reduce their risk of dementia. The Federal Health Minister supports us and agrees with us that dementia should be a priority. Unfortunately, I don't think his Cabinet colleagues feel the same way. The Minister has urged us to keep raising our voice, and we certainly intend to do that. Our first speaker this evening is Baroness Susan Greenfield, CBE, best-selling author and expert on the human brain. And Susan is a friend of Alzheimer's Australia, and it's wonderful to be working with her again this evening. She is Professor of Pharmacology at the University of Oxford, where she leads a multidisciplinary team investigating neurodegenerative diseases such as Alzheimer's and Parkinson's. She is Director of the Oxford Centre for the Science of the Mind and the Director of the Institute for the Future of the Mind, part of the James Martin 21st Century School. Baroness Greenfield is a former Adelaide thinker in residence and is the author of several books, including The Private Life of the Brain and id, The Quest for Identity in the 21st Century. She's featured on many popular television programs, including Enough Rope with Andrew Denton, The 7:30 Report with Peter O'Brien, and Talking Heads with Kerry O'Brien, I beg your pardon, and Talking Heads with Peter Thompson. In July this year, she gave a series of lectures throughout Australia for Alzheimer's Australia titled A Dementia-Free Future, Fantasy or Reality, in which she said dementia could be defeated, but governments needed to get serious about dementia and commit more funding to research. Would you please welcome Baroness Susan Greenfield to the stage?
Well, good evening, everyone, and thank you very much, Ita, for that kind introduction. It's lovely to be working with you, and indeed Henry again. It seems like only yesterday when I was here. The one thing you missed out, which I take very seriously, and for me is a wonderful honour, is that I am an honorary Australian. 2006, I even have the plaque for this. I think it's because I could give a speech after the second bottle of Shiraz, because it was a surprise. Anyway, but you'll be glad to haven't been imbibing this evening. What we're going to look at is really an extension of what Ita's just been discussing, and indeed what preoccupied us in July when we were touring for Alzheimer's Australia. What we're going to do is extend the idea that we can actually combat dementia, to extend it into looking at health generally as we age, and also to ask the question whether we can at the same time, because we're baby boomers, I'm a baby boomer, can we be happy also? So let's take the two separately and deal first with health. Okay, as you've just heard, this is a growing problem everywhere, and these are the stats for Australia. But I think it's even worse than that. It's even worse than that. How many people love you, do you think? Or like you a bit? Just 10? Let's say 10, because that's an easy number. So you see here, by 2050, if there's 1 million people in Australia suffering from dementia, multiply that by 10, or even 20, and that's half or even most of the population whose lives will be devastated by this terrible condition. Not to mention the expenditure, but it's the humanitarian aspects that, of course, touch us to the heart. So clearly, if we're to start looking at the future of aging and being healthy and happy, we start here. We start here because this is one of the most devastating conditions. You might have heart disease or cancer or TB, you're still the person that you were. Whereas with dementia, that is less sure. Is it inevitable? Well, the good news is no, it's not inevitable. It's a disease of older people, but it is not a natural consequence of aging, as you can see here with these 2 brain scans with the arrow indicating a key area that can be measured routinely in living people. And you can see here in someone of 66 with Alzheimer's that there is severe shrinkage of the brain. I'm sorry, this is a very sensitive, very sensitive thing. Whereas here, in the healthy age-matched control, clearly the area of concern is much, much bigger. So we know that it's not a natural condition, so that does beg the question of where do we go from here? Well, as someone once said, when you come to a crossroads, take every direction you can, take every option. So here's one option, what are the current approaches? Well, as some of you may be aware, I'm sure with so many people here, there must be some carers in the audience. You'll be aware that the classic treatment is with Aricept or galantamine, which has been going for a long time now. There's been no new drug for Alzheimer's for the last 15 years, and that in itself should be a concern because this medication, although it slows things down and is helpful in the early stages, is not a cure. It is not a cure. The way it works is to block an enzyme that will normally destroy a chemical messenger called acetylcholine. This is therefore called the cholinergic hypothesis. Cholinergic meaning, as you can see here, using the transmitter acetylcholine. And this chemical messenger is a kind of fountain in the brain. It's very pervasive, so it would follow if the levels dwindle, then you'll get some dysfunction. Therefore, by increasing its availability, by blocking the enzyme that munches it up, you're enhancing its usefulness, its functionality. But what you're not doing is you're not stopping the cells dying. It's not telling you why these key cells are dying, and that's what we need to know. So, moreover, not all cells that die in Alzheimer's use the chemical messenger acetylcholine, and similarly there are cells that use acetylcholine that do not die. So, although it might be helpful to ameliorate the dwindling levels of acetylcholine, you're not at the heart of the problem. Similarly, there's something called the amyloid hypothesis, after the Greek for starch, because you can look in post-mortem brains and see these unusual deposits in the brain. People therefore think this is the cause. Here you can see a scheme of what the amyloid looks like. And yet this is a kind of molecular Rambo. If you introduce any cell to amyloid, it will kind of punch it and destroy it. So really the problem is that you can have amyloid present without cognitive impairments, without problems of memory, and at the same time, you can have cognitive impairments in animal models without there being amyloid there. So although this must be a cascade effect, it might be something that's related, it's secondary, it's not the heart of the problem, because it doesn't explain why only certain cells die and not others, and that's what we really need to know. Meanwhile, while we're on the case for that, there are invasive approaches, and we don't have time really to go into it in this formal part of the evening, or we could do it in the Q&A. More specifically, neurosurgery, and I'm sure everyone is familiar with the notion of stem cell technology, the precursor cells that will obligingly turn themselves into brain cells if introduced into the right context, or something called growth factors, which, as their name suggests, encourages cells to grow. But there are problems with this. Not least the actual surgical procedure itself, which will be expensive and hazardous and not very pleasant, but also the rationale behind it, again, isn't tackling the heart of the problem of why the cells are dying. There's also non-invasive approaches. We've just heard about exercise, and indeed there's some brilliant work being done in the States by someone called Gage, showing that both in mice and in humans, that if you take large amounts of exercise, you can actually amazingly challenge dogma and actually cause in adults something called neurogenesis, which is the growth of brain cells, which is hugely exciting. Similarly, in the UK, there was published quite recently that if you take heroic amounts of folic acid, then again, this can combat brain shrinkage. Others believe that if you stimulate the brain with certain games, again, you're helping. And of course you're helping, but you're not solving the problem. What we really need is what I call the anticipatory approach. What is the anticipatory approach? Well, this is more a dream or a vision, an idea, a theory, rather than a reality at the moment. We know that not all brain cells succumb to neurodegeneration. In this very famous series of paintings, there is a man who had a stroke, presented by only painting half his face with so-called neglect, but within 9 months you can see, bottom right, we have a fully formed face, showing, as I'm sure you're all aware, that sometimes when you have a stroke you can have, if not a full, at least a partial recovery of function. So we know that if brain cells are damaged, it's not a generic feature of brain cells to be lost. Something is special about the ones that do degenerate. If only we knew what it was. Now, if we knew what it was, one could imagine developing a marker that could be in the blood. So this is, I want to stress, this is hypothetical at the moment. If we knew that these crucial brain cells, the ones that are selectively vulnerable, release some toxic substance, is what I personally think they do, and if you can monitor that in the blood, then you might be able to monitor it pre-symptomatically, which means rather like we have cholesterol tests now to anticipate cardiovascular problems, perhaps we could all go and have blood tests every few months. Now imagine doing that and the doctor saying, well, I'm afraid the bad news is you do have an elevated marker, you haven't got the symptoms now, but if you carry on like this or if things carry on untreated, sadly you're going to get dementia in several years' time. But there's also good news. We now have a medication for blocking any more cells dying, for stabilizing the cell loss. And if you take that now, if you take the medication before the symptoms come on, they will never come on. So this would mean that you could have a routine blood test every few months. If there was an elevated marker, you could take an oral medication or a nasal spray, and although you'd have to take medication every day, you would stabilize the cell loss pre-symptomatically. The symptoms wouldn't appear. That is the dream, and to me it seems this is not like building a time machine, it's not like particle acceleration, it's not 11 dimensions, this is not defying the laws of physics. This is something that quite simply needs money, because it is addressing a very straightforward question, which is what is the basic mechanism of cell loss? And I have my own theory, I'm sure there's others, colleagues here who have theirs, and to be honest, I don't care who's right. It's that we actually get the money to prove that someone is, because this is the way forward, and only when we do this, will we actually conquer dementia. And look, we need to do it. Look at the sad situation at the moment. Look at the cases of dementia in terms of social and health costs, and look at the funding they get. Okay? My case rest, that's all I have to say. I don't have to prove that. What are the bottlenecks to this? Well, the reality of drug development, which usually takes about 10 years, if not more, and costs serious amounts, millions, billions of dollars. But that shouldn't stop us. We need to get on the case because it will cost us far more, both in human costs and in actual economics, if we don't do this. Secondly, we need more awareness, and that's why Ita's doing such a brilliant job championing Alzheimer's Australia by really getting it out there, getting people free and happy to talk about it, to share their feelings, to share their experiences, so that people don't hide away. Rather like with cancer in the 50s, my mother would never say cancer. She said the C word because she thought that would mean that she got it if she said cancer. And I think a similar prejudice prevails with dementia, and we need to combat that. So well done, Ita, for all you do. We need to abandon traditional dogma, and I speak here to my fellow academics who've perhaps been the casualty of risk-averse grant-giving bodies who insist that you operate within a given paradigm, because then you'll publish papers quickly and then you'll do well in research assessment exercises. Until we stand outside of that and actually challenge dogma, we're not going to find this basic mechanism, in my own view. So that's the kind of overview of dementia. More widely, what is the health landscape for us? Well, it's without question we're going from 4,000 to 400 to about 4,000 drug targets. Conventional, so we have much more prospect of better treatment. There's bespoke therapy now based on the genetic-based, and I'm sure you'll hear much more about that, on the genetic-based approaches, which also give you the facility for early screening. So instead of a one-size-fits-all medication, you will have tests geared to your particular predispositions and medication that will minimize the side effects for you personally. I mentioned stem cells earlier, a whole new approach where diseased tissue is replaced by fresh new tissue as opposed to being corrected. So all this means we're going to live healthier and longer lives without question. But it has led some people to go further and to say, well, let's go beyond this. Let's get even better. Let's enhance our cognitive abilities. And I just want to give my own take on that, because that kind of idea is still based on the idea of taking a drug which works at the gap between one brain cell and another, a so-called synapse, as shown schematically here. I don't know how many people are familiar with this, but the green mushroom-looking thing is the end of a neuron, a so-called terminal, releasing those strange-looking turquoise shapes, which are schematic transmitters, to shake hands with the white targets, so-called receptors, and that molecular handshake will then cause a signal to be transmitted along to the next cell. So you see there's a lot of scope for intervention here in terms of acting as an imposter or enhancing the transmitter itself or intercepting the handshake and so on. And people think that by tampering around with this process, they can, for example, enhance their performance, not least with manipulation of a chemical messenger called dopamine. The problem with that is we know it does many things. If you have too little, you have Parkinson's, and you can see here with Michael J. Fox and Muhammad Ali. Too much, you can have schizophrenia, as shown here schematically by this famous series of schizophrenic paintings going from a plausible cat top left to a completely unrecognizable abstract shape on the bottom. Artistically, perhaps better, but psychiatrically worse. We also know that dopamine can be linked to arousal when you're very excited. It can be linked to addiction. All drugs of addiction cause the release of dopamine in the brain, irrespective of their primary site of action. And finally, reward is linked to dopamine. So what does dopamine do? It does all these things, and it's not that locked inside the interstices of the dopamine molecule you have reward or arousal or Parkinson's. Of course you don't. So if you target that with a drug like modafinil, which is taken, I fear, by college students to enhance their memory or performance, you can see the logic is a little bit strange. Transmitters do not have a single action. They work in more than one brain area. They don't have intrinsic functions, and therefore, if you target them, they're not going to have, with something like modafinil, you're not going to have an action. So this notion of cognitive enhancement, I think, is misconceived, and it leads people to a rather strange idea of neuropharmacology. Of course, you don't just have neuropharmacology. Some people think that you can actually bring silicon and carbon together, and indeed this is already happening. There's some pioneering work by a man called Peter Fromherz in Munich, where you're actually growing neurons on silicon chips, really exciting. It follows, if you can have brains on chips, can you have chips in the brain? And the answer is yes, we can. Here we are. This is from Fromherz's work. You can see these neurons interfacing, are very happy with integrated circuits. Rather like Day of the Triffids, you can see here these blobby bits are the brain cells, and here they are happily interfaced with silicon, forming a hybrid neurocomputer. This is Miguel. This is what he looks like. He's from Brazil, now works at Duke University. And what he's done is truly astonishing in that he's actually able to analyze the electronic signature from the brain that precedes a movement, feed it into a computer so that in a quadriplegic patient, someone paralyzed from the neck down, they can then, when they generate that same electrophysiological signature, i.e. the will to move, this now can happen because the computer will operate a prosthetic arm so that the movement occurs. Really very, very exciting, pioneering stuff. But does this mean we're going to become machines? I couldn't resist this from someone at British Telecom. It shows the kind of people that operate our telephone systems are people that think this. Here we have evolution. Homo habilis 1.5 million years ago. Then we all stood up, Homo erectus. The Neanderthals didn't last long because we, Homo sapiens, outcompeted them. And here we are today. And then he says, are we going to Homo sapiens ludditus in favour of Homo machinis? That's a thought that we have. It does lead to the idea, and the reason I want to flag this, because we're talking about the future of transhumanism, which has been around for a long time. It's the idea that science can enhance our mental and physical capacities, as shown here, and shown more recently here by Terminator, and actually written about in Foreign Policy Journal as one of the world's most dangerous ideas. And again, I don't have time to elaborate my own concerns on why we would want to see better than other people, have super memories. And if you think about it, Shakespeare and Einstein and Mozart, who had remarkable brains, had one thing in common, that they were highly original, not that they were just better at this or better at that. So let's turn now briefly to a happy old age, because I think a healthy old age, yes, it is a serious prospect. It does bring with it issues, even if we can get more money for dementia research, issues of transhumanism and enhancement and where you draw the line. But will we be happy? Well, let's think about that. First, our appearance, and whether we like it or not, the medical technologies can also be extended for how you look. For example, stem cells can be used for male pattern baldness. And I don't think we should get too high-minded about this. There's a wonderful charity worldwide run by the cosmetic industry called Look Good, Feel Better, where ladies having to have chemo for cancer and therefore who have hair loss enter a program delivered free of charge at the hospitals, and women on that program who are encouraged to make the most of their appearance and given advice on how to combat the problems of hair loss actually do better in medical terms. So let's not pretend that you can separate out what you look like and how healthy you are. It is an important issue. My own concern is with plastic surgery as we go into the future, are we going to be less and less tolerant of people, say, with big noses or ears that stick out and so on, and we're all going to have to all look very similar to each other, i.e. kind of West Coast look-alike. Sorry, I hope there's no West Coast Americans here. Reproductive status, again, whether we like it or not, the technology for not just freezing but thawing a woman's eggs is now almost there. So some didn't mind IVF, you can prolong your reproductive status, but there are those that say in the future we could extract DNA from any cell in the body, combine it with anyone else's, and if you didn't mind having IVF and a womb donor, then anyone of any age or sexual orientation could have a child. I'm not condoning this, but I'm just laying it before you because we can't ignore it. You'd have the two genetic donors, the donor of the egg, the donor of the womb, and perhaps the people that brought the child up, all laying claims to parenthood. It's something we have to think about as an issue. We have to think about it. Finally, work span. This is a very sensitive issue in the UK at the moment because they've now abolished the retirement age because we can't afford to pay people pensions anymore. I think it's a lot happier here where you are not suffering the recession like we are. But it is an issue. Like this lady who's playing with a heroic number of bingo cards would be of service to the nation if she could be pressed into. Clearly David Cameron needs her, big time. Yeah? So let's think about that. Grey power, yes. Now, I think that soon he will latch onto the idea that stimulating the brain is a good thing, and also that even if you have decreased mobility and you're not particularly strong, of course, thanks to IT, you can work at home a lot. And I think that soon we will have this, certainly in the UK, of everyone working. And that could be a good or bad thing. Now, just think about it. When you meet someone, you will evaluate them or allocate them to a certain generational grouping according to how healthy they are, what they look like, their reproductive status, and whether they're working or not. And I'm suggesting that in the future, all these things could be challenged. So whilst this has normally been the fate that awaits us all, let's be brutal, you know, we all get baggy and saggy and wrinkly, and you can see the different generations here. Imagine growing up, being pretty standardized, both in terms of what you look like compared to others, and indeed from one year to the next, looking pretty much the same, being healthy all the time, working all the time, having children all the time, and then dying. Yeah, so you have this homogenized, I'm glad you find it funny. So I'm writing a novel about this at the moment, yeah? So you're just an adult, then you die. So that's one possibility. Now, what you're going to do, this is a shameless plug for my book, by the way, which explores this, available on Amazon at, I don't know how many Aussie dollars it will be, but very cheap, good value for money. But what are we going to do if we're doing this? What are we going to do for these decades where we are healthy and we've got our small noses and our ears don't stick out and, you know, we're reproducing, get a bit bored with that? What are you going to do? What are you going to do with your life? Now, I think there's various scenarios just to wipe up. The first one I call the someone scenario, which is where you define yourself by things that you own. This has been very popular in the 20th century. But I would commend this very good book, which you may have read by Oliver James, where he talks about affluenza as a contagious middle-class virus, this desire to own things. You know, the trainers that say something about you, and then you find your neighbour has the same trainers, and you enter this arms race for individuality, you know, competing, and who's got the best kitchen. Clearly, that will lead to depression, and we know that 1 in 4 people will be suffering from depression this century, WHO statistic. So someone scenario, consumerism, yes, you can be an individual, kind of conditionally or provisionally, but you won't be fulfilled. These are the sad ideologies of the 20th century, which I call the anyone scenario, and sadly now we're continuing to have extreme ideologies, both political and religious, into our own times. What with those as options? Well, a collective identity. People are fulfilled, repugnant though the belief systems may be to most of us, but you're not an individual by definition. By definition, you could die, and the movement, the narrative, the story would continue. The final scenario, which I think is typical of our current society, is what I call the nobody scenario, which is engendered by living for the moment in the cyber world. And you can see here, again, concerns raised by Time magazine. It's not just me as the grumpy Luddite. My own view and suggestions are that obsessional use with the screen may give you a higher IQ, but a shorter attention span, improved short-term memory, but a premium on icons rather than ideas. What you see is what you get. No longer metaphors or concepts. An emphasis on the sensory. You're having a sensational time. You're excited by the hearing and vision of a very dramatic screen presentation. Less empathy for others. Already there's evidence of that. More reckless, because when you play a computer game, you learn the very dangerous lesson: actions don't have consequences. Less sense of identity. Look at people on Twitter. These clearly are in existential crisis, these people. You know, look at me, I'm doing this. Look at me, I'm doing that. Because if you don't look at me, I won't exist. Yeah. So that's a nobody identity, where you're neither fulfilled nor an individual. Now, I'm sure you'll all agree that being no one, someone, or anyone is not an option that we want to spend the second 50 years doing. Endemic in human beings is the question: who am I? What do I want out of life? What does it all mean? What does my life mean? We seek a significance. And my own suggestion is that comes with creativity. It doesn't mean to say you have to write novels or be brilliant scientists or be musicians. You can just rearrange the kitchen in a new way that you haven't seen before. And that's being creative. It's joining up the dots and seeing the world in a new way. So this, I think, I'd like to incorporate into planning out how we are going to spend, if we are, and it seems we are going to live longer and healthier lives, and more of us are going to do that. I was going to call this scheme the Autumn Years scheme, but I thought that sounded too depressing. Then I was going to call it, Ita's already thought of this, the New 40, but I thought that probably sounded too much like a baby boomer being wistful. But I think the second 50 years is exactly what it is. It confronts the idea that sooner or later a lot of people will be healthy and fit and bored and not having a sense of creativity or fulfillment. So this is the scheme. First, to abolish controls for retirement and use the pension money saved to finance a second kind of career that you could do. What we could do with this is it's optional. You don't have to do this if you don't want to. You could have a low emphasis on mobility and physical strength, but a high priority on developing your individual talents and creativity in response to market needs. How would you do this? Well, you could train for new skills and employment in a new job, or you could help with starting up your own company, or you could go on a sort of database for freelance consultancies. All this you'd have help with from the state because they were saving the money on just pensioning you off. Now, even more exciting, we take another group of people that we're not concerned with at the moment this evening. They're very young. In the UK, I don't know about in Australia, but graduate unemployment is there's 80 applicants for every one job. Such individuals are entering into expensive student loan schemes where they won't pay off the debts until they're well into their 40s. This is a no-brainer. And my own suggestion is one could use the money, at least in some cases, that normally had gone to student loans, to be a loan, yes, but to set up your own company or to get training in some entrepreneurial activity. And here's the, I think, nice idea, in combination with these older people. So you have a combination of skills. So you have the young people who have perhaps the high-tech expertise, who are up to speed with the latest technologies, but lack empathy, lack interpersonal skills, lack experience of business and so on. And the older person, who's not necessarily up to speed with the high-tech, but has a lifetime of experience behind them, and put the two together so they can help and mentor each other. And it will be fiscally neutral, because the money that would come from either the person not going to university but using it instead of a student loan, and the older person not drawing the pension but using it for this. And in that way, I think we could really rethink old age. And I'm not saying that just because I'm a baby boomer. Really, old age should be the apotheosis. It should be the culmination of decade after decade of living your life, of having relationships, of having pitfalls and having triumphs, of having excitements, of having disappointments. And all that is embedded into what makes you the person you are. So why pension you off and patronizingly ask you to do Sudoku or something? Yeah? Why not do something that will fulfill you, be creative, and will actually finally be the expression of the wonderful, unique person that you are. Thank you very much.
Just trying to think about all those things you've suggested, Susan. Couldn't I just go on? Could I just start having babies and get the mother's pension or something? Or have you got rid of them as well? Food for thought. I'm sure you'll all have some questions later. Our next speaker, Professor David Sinclair, is an internationally recognised leader in the field of ageing. He's a professor at the Harvard Medical School in the Department of Genetics and co-joint professor at the University of New South Wales in the Department of Physiology and Pharmacology. He's also the co-director of the Paul F. Glenn Laboratories for the Biological Mechanisms of Ageing and a senior scholar of the Eliason Medical Foundation and co-founder and co-chief editor of the journal Ageing. Some of you might remember seeing him on 60 Minutes when he spoke about his discovery of resveratrol. In preparing for tonight, I watched an interview that he gave to Barbara Walters on American TV earlier this year. Barbara called him Dr. Oz. And David discussed his longevity discovery, which he believes has the potential to defeat many of the diseases of ageing. Now, resveratrol, have I got it right? Is derived from the skin of red grapes. However, do not imagine that you can go out and drink red wine and stay young. No, no, no. You would need, I've learned, to drink 1,000 bottles of red wine a day to get the required amount of the new pill. So I think taking it in pill form is far more preferable. I remember when the scientists first announced they'd discovered this, I think it was around about 2007, and I thought, wow, doesn't that sound fantastic? And I started putting it in all my ageing speeches, and I tell you what, when I'd finished, everyone was drinking red wine. You know, it's just really easy. I think it'd be a great success in Australia. Please welcome Professor David Sinclair.
Hello, everyone. Do I still have an Australian accent? A little bit, hopefully. I think it was this stage 15 years ago that I accepted my degree, and I still have the tie from that event, and I'm wearing it tonight very proudly. So thank you very much, Peter, for inviting me back to give a talk tonight. And I'm very, very excited about setting up research here at the university, which really has taken off in an amazing way, certainly since I was here 15 years ago, and it's great to be back. Okay, well, that was an extremely hard act to follow. I feel like we all need to take a deep breath, shake a few limbs. That was fantastic. Thank you, Baroness. That was wonderful. And but what I want to do tonight is talk about the very exciting prospect that we can do something about our whole body aging, and that includes the brain. And if I'm not successful, I think that if we spend every evening listening to Baroness Greenfield's lectures, we probably will also avoid Alzheimer's, give our brain a workout. But I'm going to talk about if you don't have access to a lecture like this every night, what can we do about it? And so I left, as I mentioned, 15 years ago to see if I could do something about aging, which I felt was one of the last untapped final frontiers of biology and medicine. And at the time, actually, it was the backwater of biology. My supervisor, Ian Dawes, I think, thought that I was crazy going to work on this thing, which seems like a pipe dream. And there are still those people who believe that this is all just hope. But I hope to convince you tonight that this is no longer a backwater of biology. In fact, it's the cutting edge area of pharmaceutical research and medical development. And actually, it's quite helpful being a professor at Harvard University, because then people by default tend to take you more seriously. And I found that to be helpful. So normally I do a show of hands. I won't do that tonight, but I want you to ask yourself a very interesting question. Do you know somebody or some people who look much younger than their actual age? I know I do. Do you know some people that are aging prematurely? And I think I can see a lot of people nodding. I think that we all know that we age at different rates, but we don't understand, for the most part, why that happens. And tonight I'm going to tell you about one leading theory about why that happens, and it actually turns out that there are genes that we think control the pace of human aging. And if they do exist, and we're pretty sure they do, that's actually the first insights and inroad to slowing this process down. And I'm not here to make people live 200 years. I don't think that will happen, certainly not within any of our lifetimes. But what's very important about aging research, and the reason that I think it's very important to fund this area, is because it has a very real possibility of coming up with a pill that can not just treat your existing condition, let's say it's type 2 diabetes or Alzheimer's, but as a side effect, simultaneously prevent 15 to 20 other major diseases. And if we're successful at that, I think that that will be a world worth living in. So what about genes? Well, there are some people who have chosen their parents and their grandparents very well. Here's the person who chose their parents and grandparents best. This is Madame Calmèche, who lived in France, and not too long ago, she died at the age of 122. And she still holds the record. But here she's an old lady, but of course, when she was in her 70s and 80s, she looked more like she was 40 or 50 and was fit and healthy. She was vivacious. In fact, this is her 117th birthday. Apparently, at her 116th birthday, a reporter said it would be great if he was able to see her next year. And she said, "I don't see why not, young man. You look perfectly healthy to me." She's great. I've got a whole list of these. And I think most of us are not even that sharp on a good day. She also said, "I have just one wrinkle and I'm sitting on it." So she's a role model for all of us. And so the point here is not to keep people older for longer, it's to keep them healthier and younger and more cognitive and delaying dementia during their middle ages. So who would say no to a medicine that was able to make most people get through their midlife, their 50s, 60s, 70s, without the fear of getting cancer and being robbed of a healthy life? And that's the sort of technology we're talking about being possible tonight. So at the other end of the genetic spectrum, or certainly the longevity spectrum is my family. I don't actually know for sure how long I'll live because my family tends to abuse their body quite severely. This is a lady who essentially half raised me. The lady on the right there is my grandmother. And if you look through our photo album, it's rather hedonistic. They're either with a glass of whiskey or a cigarette. You can flick through, you can see this is an ad for fast food chains. This is my family. They're Hungarian descent and they have one of the lowest life expectancies, and there's no question why. So, I might be motivated to help my family, but the real motivation is to help humanity, and I think we have a great chance with the technology I'm going to tell you about. So why do I think it's possible to slow down aging, and why has society, or in fact medical research, failed up until now? Well, the reason is that we've gone through a radical change in how we think about the aging process. And I think in most schools and textbooks, they still have it wrong. And so the old idea in the aging field was that our bodies are just like machines that wear out. And you often hear this at parties. If you go to parties, I have 3 kids, I rarely go to parties, but the old idea was that our bodies would just wear out. And you hear people saying, "Oh, you can't do much about that because if you were to fix the heart, something else would break down." And so by this analogy, if you had the ability to prevent rusting of the body, something else would still prevent the car from lasting, of course. But what we were missing was the now fairly obvious point, at least in retrospect, that our bodies are not just cars. We're not just machines. We are living, breathing, biological machines that take in energy and can use that energy for repair. And so what we were missing actually was, again, using this car analogy, that there are actually genes that control our body's repair. And I think for millennia, if not for the whole history of humanity, we've been aware that our bodies have remarkable capabilities of self-healing. We haven't really understood why and what's going on, but I think we've found the genes that control these repair processes. And so it's my goal in my lab, and I actually stand here representing hundreds of labs around the world that are trying to find who these guys and girls are and get them to get out of bed earlier in the morning and work harder to keep our bodies healthier and disease-free for longer. And so there's a new concept in the field and that is that our bodies can repair and that there are genes that control that. And the reason we know these genes exist is actually from pioneering work in the 1990s. Scientists by the names of Cynthia Kenyon, Lenny Guarente, for example, these are legends in the field who studied simple organisms like yeast and little nematode worms and fruit flies, and discovered that a single mutation in those organisms can greatly extend lifespan. In the case of the worm, they doubled lifespan just by mutating or disabling one gene in that organism. So the new concept is that aging can be regulated, and there are key genes that control that. And what was a real breakthrough also in the last 5 to 10 years is that these genes are actually under the control of what we eat. And you may have heard about this diet called caloric restriction. Basically means, at least if you're an animal, you have to cut back how much you eat, about 30%, which is something I tried for about a week and gave up. It was horrible. I don't recommend it. Kudos to those who can. But also the point is, if you're wondering, oh, why don't we just ask people to diet or just exercise heavily? Well, if somebody is frail and old, disabled, suffering from multiple diseases, you cannot expect them to go on a diet, certainly not cut out 30% of calories, and nor can you expect them necessarily to undergo heavy exercise. So we need a pill that can harness the body's natural defenses and actually trick it into thinking that it's just run a marathon or that it is calorically restricting. And these are the genes that I'm going to talk about tonight. These genes were discovered to be involved in aging just as I arrived in the United States, and I was very fortunate to be part of this team that realized that in this organism, which is the yeast cells that you use to make bread and beer, that they have a single gene that controls their aging called Sirtuin. And this gene, if you put in one extra copy of Sirtuin, the yeast cells can live 30% longer on average. And this was a really exciting discovery, that there's a single gene that can extend lifespan in this organism. What was more exciting was that as the genomes of mice and humans were coming out, we realized that this Sirtuin gene existed in essentially all life forms on the planet, from plants and bacteria, and also mice and humans. So we thought, and what I've been doing for the last 10 years, has been trying to figure out whether these Sirtuin-like genes in our bodies also control aging and how we might harness them for medicine. So here's a picture of a Sirtuin. Okay, so that we actually have 7 of these genes in our body, and they make proteins. Here's a picture of one of these proteins made by the genes. They're called Sirtuin 2, 3, 4, 5, 6, 7. And they're in different parts of the cell. Some are in the mitochondria, which are the power packs of our cells. Some are in the nucleus controlling which genes are switched on and off. Here on the right-hand side of this slide, you can see that my lab's been trying to make small molecules that may be drugs that can turn on these proteins. And I'm going to talk about that in a minute. But what do we know about these Sirtuins? Well, when we published our papers back in the mid-1990s, there were maybe two scientific publications per year on this topic. Now there's at least 1 per day. I think we're up to about 3 per day. It's an amazing change and explosion of knowledge. And Sirtuins aren't the only set of longevity genes. There are actually 4 nodes, as they're called, that are communicating, sensing what our bodies eat, how stressed we are, and they turn on the body's defenses. Okay, so here's what the Sirtuins do. No, they don't direct traffic, but it's a good analogy for what they do inside the cell. They tell other proteins what to do. And so when an animal is calorically restricted or has just undergone exercise, the Sirtuin enzyme will clip off little chemical groups like a Pac-Man off other proteins, and now that they've had that clipping process, they're now more active and they go off and they might repair DNA or they might protect a nerve cell, a neuron. They do many things, but it's extremely complicated and we don't understand everything, of course, at this point. But because there's so many researchers studying Sirtuins now, we do know quite a lot. And this is just an example of some of the organs that we know are protected by Sirtuins, at least in animal studies. You can see that Sirtuin, which is the most famous Sirtuin gene, in blue, responds to how much an animal is eating. If it's dieting, there's more Sirtuin. And if you exercise the animal, there's more Sirtuin. And we actually think that Sirtuin and other Sirtuins may underlie many of the health benefits that you get from dieting and exercise. But that's not an excuse to sit on the couch and just pop a pill, because what we find is that when we combine our drugs that turn on this pathway, they actually work better if they're given in combination with low-calorie diet. So this is an adjunct to a healthy life. And you can see that this gene protects the brain. In fact, we can delay Alzheimer's in a mouse at least. Protects the heart, the liver, there's fat cells there. The pancreas is very important for type 2 and type 1 diabetes. It puts out insulin. And one of the most interesting parts of this, or aspects of this function, is in skeletal muscle, our muscles. And we find that when we treat the mice with our compounds, our drugs, or we engineer them to have an extra copy of this SIRT1 gene, they become super fit and they have more energy in their muscles. And so I'm not saying that we'll have superhumans. I don't think that that's the goal, but we do know that frailty and a lack of energy actually limits the quality of life for many elderly. Okay, so you cannot genetically engineer humans, and I never would advocate that, nor do you have a chance to if somebody's just come in on a gurney into the emergency room. What we need is this medicine. I think hopefully you're all convinced of that. But the way to do that is quite a long process. As Baroness Greenfield mentioned, it's about 10 years and about $1 billion. And we started this process back in 2003, looking through hundreds of thousands of compounds for any that would turn on this SIRT1 enzyme in the test tube. And we found about 20 in total, and we published them all. There was one that stood out, not just because at the time it was the most active, because when I Googled it, it turns out it's in red wine. And the last 8 or so years has been a lot about red wine. But importantly, we were not studying red wine, nor do we study red wine. But it's a very interesting proof of concept molecule. It's hard to say. I didn't give it its name. It was already in the literature, but the amount of papers has gone from maybe 5 per year up to close to 5,000. So resveratrol looks like this. It's a very small molecule, and you can get it in very tiny quantities in red wine. But again, this is not the point. I'm not saying that we're going to be using resveratrol to prevent Alzheimer's anytime soon. There are some problems with resveratrol as a drug. It's not very available to the body. So I think we can use resveratrol, and we have, as an experimental device. Many scientists study this. But I think that the way forward in terms of medicine is to develop a synthetic drug-like molecule that works like resveratrol, but is much more potent and potentially more specific. But we used resveratrol. We had a lot of fun with resveratrol a few years ago. We were feeding resveratrol to the yeast cells, and they lived longer, about 30%, up to 60%. The worms, you can see in red, the little red worm lived longer. The fly lived longer. A group in Italy published that resveratrol extends the fish lifespan, almost 60%. So anyone who sells fish food may want to put some resveratrol in there. But importantly, resveratrol is also an antioxidant, a weak one. So it was important for us to show that it wasn't just being an antioxidant, but it was working through this Sirtuin gene. So we were able to delete the Sirtuin gene in the yeast and the worms and the flies, and now the drug didn't work anymore. It didn't extend their lifespan. So that was a very important piece of evidence that we were on track. Now, what about mice? Well, I'm going to show you some of that data, but in case I forget to tell you, in all my excitement, the effects that I'm going to show you, many of them we've looked at specifically. So, for instance, in the muscle, we can turn off a gene in the mouse. It's amazing technology. We can engineer mice so that if we feed them a certain molecule, it turns off the gene in their muscle. Okay, they're fine. Don't worry. They're actually fine. But what's important is then when we feed them resveratrol, the effect is not seen anymore, just like we saw with the yeast, worms, and flies. Okay, so what happens with resveratrol? Well, here are some of the mice that were in the study that we did with actually 15 different labs from around the world. So I'm just very thankful that I get to work with so many great researchers and get to talk about it. Okay, so one thing you'll notice from this slide is that the mouse on the right that is on a high-fat Western diet, basically it's equivalent to the average American diet, is still fat. So resveratrol did not make them thin. So we were really worried that nothing was working and that our hypothesis which at the time was we can mimic caloric restriction, that was out the window. But then when our collaborators first opened up the mice on the right, it was amazing. Their organs were as though they were lean. They still were fat, but their organs were behaving and physiologically as though they were super fit. So their arteries were clean with resveratrol versus the fat ones. Their hearts were stronger. They had less bone loss. Their livers were perfectly healthy, except that they were fat. So this was really quite a remarkable discovery, and it's been a controversial field actually, because people have been trying to understand what's underlying this amazing effect. And again, we believe that a lot of it is through the sirtuins, but resveratrol is what you would call a dirty molecule. So there are certainly other things that are going on, but we think that sirtuins are clearly important. So now what happens when you test these mice for physical health? Okay, so this isn't a study from my lab, but it's a great video that was sent to me by a lab in Switzerland, Johann Overichs. And I can't help but show you this. This is what happens when you feed resveratrol to mice and put them on a treadmill. Do we have any sound on that? Okay, so I'm going to let you guess which is the mouse on resveratrol. It turns out the mice on resveratrol ran twice as far on the treadmill without ever having trained before. They were super mice. And their muscles looked like you would see if you looked at Lance Armstrong, full of those energy power packs. Okay, enough said. I think you get the point. The mouse, if you're guessing, with on resveratrol is the one on the right. Okay, so the one on the right was the super mouse. And again, the point is not to make mice run further or even people run further. It's to understand how to prevent frailty. Okay, so I hopefully have convinced you that this is quite an amazing molecule, and that you'll take my word for it that it's not going to be a medicine, probably. And so what I did was I founded a company that is still in existence and is conducting clinical trials, not just in mice, but actually in people right now. There are hundreds of people taking the offshoot of this research. So what do these molecules look like? And I'll tell you a bit about how they're going, those trials. This is a paper that was published. It was a high-profile, highly controversial paper that people are still arguing about in the high-profile journal Nature. And here's what these molecules look like. Basically, to you, if you're not a chemist, they look like chicken wire. But hopefully you can see that resveratrol on the left versus these other molecules is quite different. And these are the molecules are actually derivatives of these that are currently in about 100 or more patients. And I say patients importantly because we're not trying to cure aging. We're treating diseases just like a normal medicine. And if the drugs make it to the market, which may be somewhere between 5 to 10 years if we're successful, then these would be true drug-like molecules and approved by, in America, the FDA, and would be prescribed for a particular disease to treat. So the type of diseases that the molecules are being tested in range from type 2 diabetes, metabolic diseases, as well as inflammatory diseases. And so inflammatory diseases includes things like arthritis and even inflammation of the skin. So these might be the first uses of a potential longevity drug. But they have to have a use. We can't treat aging. And so initially, the results look promising. There's been some public reports now from these human clinical trials in just a few patients that there's statistically significant changes, as you would expect, to suppress inflammation in humans. So this is perhaps, if we're lucky, the first signs of a real revolution in what we can do in medicine. But again, it's very risky, and I'm not here to say that it's at all a done deal. Long way to go. But what can we do in the meantime while we're waiting for these medicines to be produced? Well, it turns out that there's actually a genetic basis for longevity, and there are genes like SIRT1 that seem to affect our predisposition to diseases. And this is one paper that I was fortunate to be part of. I think it came out last year in the journal Endocrinology. And what this is saying is that people who have a certain variant of this sirtuin gene have greater energy. They expend more energy. You know these people that can eat the chocolate cake and they never get fat? That's these people. Don't you hate them? And they're insulin sensitive, and what that means is that they're at the other spectrum from type 2 diabetes. So perhaps there is certainly likely to be a genetic component, and perhaps this gene is involved. And so in the United States, actually, you can test yourself for your genetic traits. There are companies that actually do this. It's not currently, I believe, available in Australia, and I think it may in fact be prohibited. But in the United States, you can just get a kit online, and this is my son, Benjamin, testing to see what his genetic composition looks like. And he was very excited. We learned a lot about genetics. He's spitting into this tube, by the way. It takes about half an hour to fill up this silly tube with spit. But you send it away, and you get back a genetic result. And of course, for the diseases that are very sensitive, information-wise, and you may require counselling, those are hidden from view until you provide consent. But typical things like your predisposition to type 2 diabetes or potentially your longevity, these things you can see. And in fact, it's quite fun and it's an educational experience. Okay, so Ben actually turns out to have one of the good variants of the SIRT1 gene. And so he's very excited about that. He might live longer. But also I think that what's important to realize is that his generation could be the lucky ones to benefit from this new type of research that we're hearing about tonight and the breakthroughs that are possible. And the future really looks bright for medical research. And I'm just here to tell you, I've told you a little bit about some of the exciting work that's going on. And I want to finish by saying that the good news is that my grandmother, who completely abused her body when I was a child, is still going strong. I visited her yesterday, and she's really on the ball. She's got no sign of dementia. And it's just been wonderful for her to see her great-grandkids grow up. And what I hope with this research is that, that everyone will get a chance to see the great-grandkids grow up and see them perhaps stand on this stage and graduate. And I want to thank you again for inviting me. Thanks for coming.
I'm delighted to introduce our final speaker this evening, Professor Henry Brodaty, Australia's foremost expert on Alzheimer's and a former state president and national president of Alzheimer's Australia. He's a Professor of Ageing and Mental Health and Director of the Dementia Collaborative Research Centre at the University of New South Wales. He's also Director of Aged Care Psychiatry and Head of the Memory Disorders Clinic at the Prince of Wales Hospital. Professor Brodaty is currently leading the New South Wales Dementia Policy Team, which has drafted the 210-2015 Dementia Services Plan for New South Wales, and recently the Federal Minister for Mental Health and Ageing appointed him to a panel set up to review health and medical research in Australia. He's listed in the top 1,000 scientists publishing internationally in the field of mental health. Ladies and gentlemen, Professor Henry Brodaty.
Thanks very much, Ita, Chancellor, Dean, distinguished guests, friends and family. A lot of you here. So I'm going to be talking about healthy and happy ageing, paradox or possibility. And, wrong one. Here we go. So this is a local school near me, and it's a metaphor of what's happening in society. You can see what's happening. The school is closed, the windows are broken, 1,000 children no longer here. It's going to become a residential aged care facility. Why? Well, this is 200 years. People aged over 65 are just going up and up and up. Children under 5, down and down and down. Just in the 50 years of this century, the last 50 years, or the next 50 years, we're going from 2 children for every older person to 2 older people for every child. So how will we age? Will it be like the person on your left or the person on your right? Will it be like Mick Jagger or like being in a nursing home? Will it be active or being dependent? Will it be turning 100 or being fed? So, people age differently, as we've heard. So this was the original patient that Alois Alzheimer, a psychiatrist in Germany, described, and when he sectioned and examined her brain, described the features which now bear his name, Alzheimer's disease. This man got married last week at the age of 69. Looks pretty good. 71. But maybe the role model should be... So, as David Sinclair has told us, we age differently as we grow older. But how can we do it well? Now, there are many positive aspects of ageing. In fact, most people who are older are doing it pretty well. Most of us, and I'm now getting almost into that area, are living in private dwellings. 3/4 of people aged 85 or more are living in private dwellings. 1/4 of people aged 65 or more are giving help to their families rather than getting help from their families. 2/3 of older people say their health is good to excellent. 1/3 of older people are doing voluntary work. The third, or golden age it's sometimes called, of what people aged 65 or more are doing. Why is this happening? Well, patterns of disease have changed. The 19th century was the century of infectious diseases, but since then we can see that death rates have just been steadily dropping. Now, infection causes a very small percentage of deaths. Heart disease. From about 1970, rates of death from circulatory diseases have been steadily dropping, a triumph for public health and cardiology. But neurodegenerative diseases have been rising, particularly in the very old, but even for the whole population. Deaths from neurodegenerative diseases are rising, and the 21st century will be the century, from a health point of view, of neurodegenerative diseases. So if we want to lead a healthy and happy old age, then that's the target. So is dementia inevitable? We know the rates rise steeply with age. 5% of 65 plus, 20% 80 plus, 30% of 90 plus. But the flip side of that coin is the percentage of people not getting dementia. It's not inevitable. And I've been inspired by the same person as we heard from David Sinclair, as I'll show you. So we've seen these figures. We have something like 36 million people in the world with dementia, doubling every 20 years, one new person every 7 seconds, 116 million by 2050. It would be the world's biggest economy in what we're spending on dementia. It is now. The 18th biggest world economy. We're quadrupling in Australia from 250,000 to almost 1 million people. What is dementia? It's an umbrella term. It means loss of cognitive functions and functional abilities. There are over 100 causes, and Alzheimer's is the most common cause. It's a democratic disease. Anyone can get it. Politicians, film stars, and Australians. And a special tribute to Hazel Hawke as the first public figure in Australia to come out and talk about her dementia. Ginny Little and Don Lane. So what's going on in the brain? Here's Augustita, and what was happening in her brain is it was shrinking. Instead of being about 1.5 kilograms, it was half that size. It was shrunken, it was shriveled, and the brain tissue had been dying. There's a build-up of the abnormal protein in the brain called amyloid, or the beta protein, and it's forming these plaques on the left, a dense proteinaceous material surrounded by a halo of inflammatory cells and dying nerve cells. And on the right, the twisted filaments within the nerve cells leading to those nerve cells dying and forming neurofibrillary tangles. So can Alzheimer's be prevented? Well, the short answer is probably not. But here's the same person, David Sinclair. This is John Calmont, born in 1875. She took up fencing at 88, rode a bicycle till she was 100, poured olive oil on her food and onto her skin, drank port wine, smoked 2 cigarettes a day and ate 1 kilogram of chocolate each week. And she died at 122 without dementia. She's my role model. But, I mean, I love cycling. But we can't eliminate the disease. I mean, there is a paradigm, like with smallpox, which we have eliminated from the planet. And potentially we could do the same with Alzheimer's, but that's really some time off. A more realistic probability is delaying the onset of Alzheimer's disease. And if we could just do it by 2 years, that would reduce the prevalence by 20%. Reducing it by 5 years, delaying it by 5 years, would reduce it by 50%. Ideally, delaying it till after we died would be the ideal we'd all want. Okay. So there are public campaigns. Alzheimer's Australia has got a 7-step program, Mind Your Mind. And there are 7 steps within that, which I'll go through. What we're learning is it's a whole-of-life approach. It may be things that are happening in the uterus right through to things that are happening right now in all of our lives. And the other message is it's never too late. You're never too old to be doing some of these things. So physical activity, we've heard about that. We've heard about the people in the nursing homes in Western Australia doing all these things to improve their health. And there are many studies showing that physical health doesn't stop. It delays or mitigates cognitive decline, the onset of Alzheimer's, vascular dementia, the second most common cause, or dementia in general. And the news is more is better. It's not just the stroll, it's getting puffed, it's working up a perspiration, or pushing weights. At least 3 times a week, and accumulating 150 minutes a week. So it could be half an hour, 3 times a week, 10 minutes, 15 times a week, whatever you want. If you're going to embark on this, check with your doctor. This was an elegant study from Perth. Non-exercisers, people aged over 70, worried about their memory, were randomised either into walking 3 times a week or continue with their non-exercise. And they measured their cognition. This was Nicola Lautenschlager from Melbourne. And what she showed is the exercises, in this slide, down is better, and the darker bars are the exercises. Their memories improved. And over 18 months, the trial went for 12 months, but they kept doing it. They got into it. The non-exercise initially worsened and then stabilised. But here was a proof of concept. Exercise matters. And in a study published this year, what they looked at was the size of the hippocampus. The hippocampus is these areas in our temporal lobe. It's our short-term memory centre. And what it's showing is the people who were exercising, the hippocampus was getting bigger, neurogenesis, growth of nerve cells. Whereas the people who weren't exercising were having the normal age-associated atrophy. The second step in the program is Mind Your Brain. And again, there's accumulating evidence for the benefits of mental activity. Michael Valenzuela and Paminda Sachdev from this university reviewed 22 studies with 29,000 people and showed education, occupation, high IQ, leisure with complex mental activities, each of those reduced the risk by about 1/2. That was over a lifetime. When they looked specifically at late life, increasing complex mental activity reduced dementia by about 1/2. This is epidemiological studies. Even in late life, the never too late story. And there was a dose-response relationship evident. So complex mental activities at any stage in life have a beneficial effect. Now, there are Nobel Prize-winning marathon runners who will get dementia. These aren't going to prevent you getting it. They're going to delay the onset or reduce the risk. Diet, there's some evidence for antioxidants, and we heard something about that, and for the Mediterranean diet. Again, these are epidemiological studies. You can't do a randomised controlled trial over many years with big populations to demonstrate this. Is there evidence for alcohol? Well, there is some evidence for moderate alcohol intake being beneficial. Heavy alcohol intake is not. There's soft evidence for fish, seafood, omega-3 and vitamin D. Very soft evidence for caffeine being beneficial, but not for vitamin Z or C. Smoking is a risk factor for Alzheimer's, but the good news is if you give it up, that risk goes away. Mind your health checks: blood pressure, cholesterol, sugar. We should all be attending to these. This was a study of 5,000 women. 500 of them had the metabolic syndrome. What is that? It's a combination of having diabetes or high sugar, abdominal obesity, high cholesterol and high blood pressure. What was interesting was each element that a person had, these women had, increased the risk independently. So the combination was risky, and the more elements, the more the risk. This year there was an interesting review published by Barnes and Yaffe looking at the population attributable risk of 7 risk factors for dementia. And what they calculated, if we could reduce these risks by 25%, it would lower the numbers of people in the world with Alzheimer's, specifically for Alzheimer's, by 3 million. So 3 million out of 36 million less, fewer. And what were these 7 factors? And this is the population attributable risk in percentages for the whole world, looking at the world as a whole. Diabetes type 2, midlife obesity, midlife high blood pressure, depression, physical inactivity, smoking, cognitive inactivity or low education. And they redid the analysis just looking at the United States. And not surprisingly, the 2 factors that were most important were midlife obesity and physical inactivity. So these are things which are eminently modifiable. For the world as a whole, low education and lack of cognitive activity, and particularly in developing countries, was the major risk factor. So we can prevent it, maybe not, but we can delay it or mitigate it. Can we treat Alzheimer's disease? As we've heard, there are drugs for treating the symptoms, but not the underlying disease. It doesn't stop the pathology. These are the drugs currently available around the world. What about drugs that actually modify the pathology? Here are the number of drugs that can do that now. That's right, there aren't any. Okay. That's despite 20 years of research. That's despite me getting up in lectures and saying in 5 years we'll have a drug for Alzheimer's that will cure it. I've been saying that for 15 years. There are plenty of promising leads, and we do drug trials at Prince of Wales Hospital and have been since 1989. And some of these might actually crack it, because to get a drug that will cure Alzheimer's or stop it in its tracks would be worth $20 billion a year in sales. But all the drugs to date have failed, and we've done trials with many of these drugs listed here. They all look good. They look good in the laboratory. They look good in the mice. They don't work in the humans. But there's hope. There's also a lot of interest in natural therapies. Will ginkgo work? Will folic acid and B6 and B12? We heard about that study in Oxford which showed that it reduced the shrinkage of the hippocampus in people with high homocysteine levels. Most of these natural therapies don't have an evidence base, so we don't know yet if they have a benefit. People love taking them. So the paradox is, we're living longer, we're not dying as often from heart attack or from stroke, but the consequence is we're more prone to develop age-associated conditions, such as dementia, macular degeneration, problems with walking. So what do we do? Well, we should be doing more of these preventative strategies. We should all be doing them. It should be part of our daily life. But people will get dementia. I said there is 250,000 people in Australia right now. And for them, Ida's right, we need to do much more. Better community care, better residential care, better management of behavioural and psychological symptoms of dementia, which are the greatest burden. Better support for families. Government policies, services. Our workforce for ageing is ageing more rapidly than the people they're looking after. And we have a deficiency now which is just going to get magnified over the next 40 years. We need something like 500 new beds in residential care a month for the next 40 years just to keep pace for dementia. And of course, more money for research. I could show you exactly the same bar graphs that Susan Greenfield showed you, which shows that for every dollar spent on care, we're getting less than 1 cent, 0.1 cent in dementia research. So let me just show you a quick video of what we can do to improve the quality of life for people with dementia. If we could just show that.
We were concerned about the quality of life of residents in nursing homes and their high levels of depression and high levels of social isolation and loneliness of people in nursing homes, and we wanted to address these problems. We found that the level of agitation in the chemotherapy group decreased significantly over the 12 weeks of the study and stayed low at 26 weeks compared to controls. This is about a 20% on average decrease.
Do you think I should have it in plaits? Actually, you'd look nicer with that.
The chemotherapy consisted of a clown doctor specifically trained to work with elders in nursing homes, visiting the home for 2 hours each week for 12 weeks. As well as that, we trained one volunteer from each of the homes to be the laughter boss. The laughter boss was someone who carried through the humour into everyday practice and encouraged the other staff at the home to do so.
I think humour provokes the playful self, and that is that you're using humour to provoke them into a response and to play back and to make a contribution. It's that lovely quote by Dr. Stuart Brown. It's the stick that stirs the drink, so to speak, humour and play. And so you're stirring them up to give a response coming from the heart. Once they know you're genuinely there for them, you're not putting them down, you're just teasing them ever so slightly.
Somewhere else. All right, now Norma, you say, "Oh, help me, help me, help me. I can't pay the rent. Who will save me?"
Pay the rent.
I'll have to get an agent now.
A high proportion of residents in nursing homes have dementia, and agitation is one of the symptoms of dementia. And we think it's partly caused because they can't express themselves very well, so you don't know what their needs are, if they're hungry or thirsty or in pain.
Some of the people could not be understood on an intellectual level, like they were speaking gibberish, but it's amazing in that gibberish that emotionally they were really telling you how they were feeling. I would respond in a way, speaking the same language back to them. It's an old-fashioned approach that commedia dell'arte companies would use when they were travelling through foreign countries. So they didn't have to really speak dialogue. They were going, and so all these sounds and words and gesture I could use to communicate back and forth with them, and we would go places that were just phenomenal.
Behind the dementia, there's a real person. There's a person with a past, with loves, with likes, with taste, with passions for different things. And dementia doesn't just wipe out the person completely, memory. It's like the erosion of different parts of the brain. But there are islands, even whole continents of brain, which are still there. And the skill is trying to tap into those.
Right, so I've got this flock of sheep in my back garden.
Deep respect and a great knowledge of who they are. You know, they could be, worked as a wool classer, so you get that background, whether they married, how many children they had, where they grew up, all of that, the family story. Like, I remember your daughter saying that you ended up putting a frog in her sleeping bag when you went on holiday down at Rosebud. Who told you that? You know, that kind of stuff.
When we looked at the people, they were often sitting mute, apathetic, but when we engaged them in their activities, they came to life. They started smiling, they started interacting, they took part in theatrical performances, they played this mock game of tennis, an English teacher listened to poetry being read and you could see this beatific smile spread across her face.
What would you do now you're in charge of the world?
I'll knock you out.
Oh, thanks, that's me gone.
Well, I'd like humour therapy to become a mainstream psychosocial intervention in nursing homes, the way that we would use massage or music therapy or aromatherapy now. Yeah, so I'd like it to become part of the arsenal on how we tackle challenging behaviours in residential aged care.
If they're enjoying themselves more, their transition into the next world is going to be more relaxed, more calm, and more centred. They'll be carrying less angst, less baggage, I think. So I see it in a sense as a bit of a peripheral midwifery role. And I think as you need help to get into this world, you need a lot of help to get out gently and with love and compassion and empathy.
So that's a trial that we've just finished, and we showed a 20% reduction in agitation and a decrease in use of medications. The point being that healthy and happy, we're all hoping for that. We may not all get there, but we can still have a positive quality of life. So let me finish off by saying, look after your brain and your body. Dementia is a word, not a sentence. That's our website if people are interested in looking at our research. And if you're interested in hearing more about positive brain ageing, there's a free forum next Monday from 10 to 1 at South Sydney Juniors Leagues Club, and there's some flyers out the front. Thank you very much.
We now will open to questions. We are running a little over time, but the organisers think we should do about 10 minutes for questions. So I've got some here that have been SMS, but is there anybody in the audience that would like to ask a question? Please put your hand up because there are microphones and we can take questions from the floor. A question to you, Susan, while we're waiting. How to deal with ageism in the workforce and the second career post 50?
How do we deal with it?
Yeah.
Okay, so I think that, first of all, the idea is that it be optional. If people wish to retire and spend time with their grandkids or doing the gardening or playing golf, that's just fine if that's what they want to do. But for many people, they feel disempowered, they feel they're not useful anymore, they feel undervalued. And I think that one could have a scheme whereby there are options, and they are just that, and that you could, if you've been a professional person, you could register on a database and be a consultant, not necessarily full-time, but that would be one possibility, or you could retrain, or, and I think this is quite fun, you might actually start your own business if you had mentoring and help. The absolute key is that you shouldn't just be launched to do this on your own, and I think the government, the public sector, have a role in perhaps using some of the money that would otherwise go for pensions and the like, to actually have schemes that are mentoring and introduce people to each other and are there as a backstop for providing help and advice as you do this. And of course, the idea would be if you made lots of money, if you were to start with a business, make lots of money, you can always pay it back, so that that would then increase the pot of money for expanding the scheme. And if you did it with young people as well, I think that would also increase the chances both of keeping your brain active and young, working with younger people, and at the same time giving those young people the benefit of your experience. So I can't see a downside other than the issue of bureaucracy, organisation, and the normal machinery of government. But if we will lobby for this, if you lobby for this, then it's possible, surely, because government's there to serve us, not the other way around.
Thank you, Susan. Are there any questions in the audience?
Does the panel see some connection between the links of where we see this humour therapy, old people and young people engaging together, and obviously the genetics that were touched on? But what seems to be coming through is that it's that engagement between people not being isolated and removed and still engaging with people who are vibrant. Is that something that people see a link through?
It was hard actually physically to hear you, but I think your question was about social isolation being a negative factor for ageing. Is that the essence of it? Okay. Well, there is one of the other steps in the Mind Your Mind program was in fact combating social isolation. And if you look at people in middle age and look at those who are more socially isolated, they actually have a faster rate of cognitive decline. It may be that, and these people without dementia, maybe they've got sub-syndromal dementia and that's causing their cognitive decline, their social isolation. But the follow-up periods have been, say, 10 or 15 years, are still showing that. So it's unlikely that's total explanation. So it may be that socialisation is actually beneficial as well as being physically active and mentally active, although the evidence for that is not as strong. When Marilyn Albert was here 2 years ago as a visiting Alzheimer's professor, she said she'd like to combine physical exercise, cognitive exercise and socialisation, and she thought shopping was the answer.
Woman after our own hearts. I like the sound of her. Right, question please.
Hi, sorry. One comment and one question, please. Professor Brodaty treated both of my parents, and for such a busy, smart person, he's a very genuine human being. I thank him for that. But also just a question to Professor Sinclair. I had a book 20 odd years ago, maximum lifespan by Dr. Roy Walford, and he was advocating calorie restriction, and that seemed quite encouraging at the time. But is that something you commented on? You think that that's maybe a possibility by restricting calories, in part?
Yeah, did everyone hear the question? Do I believe in calorie restriction for humans? Well, Professor Walford, who I knew is no longer with us, that was an irony that he did not live longer. Now, I'm not... He was a wonderful man. No, but in all seriousness, the underlying biology of what calorie restriction does, I think, is very powerful. And I don't know, nobody knows. Anyone who says they do is lying, whether this will work in humans. Some people argue, there's a colleague of mine at Harvard that says humans have reached their maximum lifespan. All this stuff you're doing, David Sinclair, is a waste of time. I totally disagree. I think that whenever we've said there's a limit to human anything, we've broken that limit. But there are studies of people who are calorie restricting. I know some people have been doing this for over a decade. And although we don't know if they're going to live longer, their basic disease status, so their arteries and other parameters that you can measure, they do seem to be younger. And they certainly are loving life. They're usually very full of energy and love what they do. So we don't know yet, but the evidence is that it does improve health. I just don't know many people who can do that.
Can I just ask, I read somewhere that mice, copulation goes down there. So it might be a high price to pay. You know.
Well, usually they're depressed.
Yes, if you stand up, there we go. I wouldn't want to be a mouse.
Can I please ask and even suggest if at next free meeting that you've got on the 24th of this month, that we invite politicians, especially the Minister of the Aging and the Minister of Health, because it is a lost battle that we try to do whatever we can if we are not encouraged and given the possibilities to achieve what we are trying to do. And I thank you all for having really done this seminar for us. Thank you very much.
Not really a question, just a nice thank you. Thank you very much.
We have the Director General of Health here with us tonight, and I'm sure she'll relay your message.
Could you discuss the role and mechanism of melatonin in aging? One of you like to answer that? Susan, you're suffering
I'm
from
thinking,
jet lag.
I'm a beneficiary of melatonin. I take it for jet lag medication.
It works.
Yes, because for some
obviously
people,
works.
In certain people, I've heard anecdotally they get depressed with melatonin. Actually, other people say it doesn't affect them at all. Other people, like me, think it's beneficial. That might be a placebo effect. So I think the jury is still out, and I think the brain is so complex, the individual brain is so complex in terms of the cocktails of chemicals, their conjunction, the levels fluctuating and so on, that it may be under certain contexts, it can help you, for example, overcome jet lag, and other times it will cause depression. And I would be very hesitant to make a blanket statement about melatonin, and certainly about it in the long term over aging.
There's a few skeptics out there, so few questions along this line. Modern science and medicine seem to help more people grow older, and ironically give us all a greater chance to experiment ailments and disabilities associated with them. David?
We have a greater chance of experimenting on animals? Is that
Well, if we grow older, we can grow older, but ironically it gives us all a chance to experiment ailments and disabilities associated with aging. Quite
if we
a few
are
questions
successful,
along that
then we
theme.
don't need to experiment so much on animals.
Sorry?
If we are successful at making these medicines, then I hope there's one day when we don't need to continue doing medical research. But until that day comes and people don't get sick and suffer from diseases, then I think that medical research is essential.
Yeah.
Right.
Can I just endorse that? Because there is a public perception of that scientists sort of deliberately and for no reason inflict pain on little creatures. Please, I just say this because it's really important we say it over and over again. No animal in Australia or UK will be in pain. They're under very strict regulations. And I would say to you, if you have your mother or someone you love wheeled in on a gurney and you have a rabbit wheeled on a gurney, who would you want to save?
I don't know what the pineal gland is, but I know one of you will. What role does the pineal gland play in aging, particularly in an increase in the incidence of Alzheimer's and dementia?
None that I know of.
No, this is the kind of melatonin question as well. The pineal gland is something that is supposed to be sensitive to light and to the light-dark cycles. I'm not an endocrinologist, so I can't say in detail, but clearly this is the same questioner who's clearly been thinking about light-dark cycles, melatonin, jet lag, and pineal gland.
Okay, well, I think, unfortunately, we have come to the end of question time because it is 5 to 9 that we are, as I said, running slightly over. I would like to invite the Dean, Professor Peter Smith, back to the stage, and I hope by now that I think we can all agree that the possibility of healthy, happy ageing is very real, and we look forward to it.
Look, thank you. Ladies and gentlemen, this does conclude our event this evening. I have a few things to do in bringing it to a close. Firstly, I'd like to thank our speakers and our facilitator. I'd like to thank Ita Buttrose, and I'd like to thank Professor Susan Greenfield, David Sinclair and Henry Brodaty for such fascinating and compelling presentations and discussion. There are some other people that I need to thank. And first of all, I'd like to thank Dr. Matthew Miles and his team, and especially Erica Ford and Maria Backlund for making this event happen this evening. I'd like to also thank Maxine Rich and Mary O'Malley. I'd like to thank Wendy McCarthy, who is actually a member of my Medical Dean's Circle, and Mr. Glenn Rees from Alzheimer's Australia. The next thing I need to do is to remind you that we have feedback forms on your chairs. Please do take a moment to complete them and hand them in on your way out. We do actually read them, we take a lot of notice of them, and we will use your feedback in planning these events for next year, so that's very important. So finally, I'd like to thank everybody for attending, and I hope you found the event both interesting and inspiring. And I look forward to seeing you all at similar events next year. Thank you.